As we peer into the vastness of space, gazing at the dazzling array of stars that fill the night sky, one profound question seems to echo across the cosmos. Are we alone in this immense universe? For centuries, this has been a question that has captivated humanity, driving us to look beyond our own world and wonder what might lie out there. Now, thanks to one of the most extraordinary achievements in space exploration, we might be on the verge of an answer. The James Webb Space Telescope, JWST, a groundbreaking instrument launched into orbit, is here to help us peer deeper into the unknown than ever before. This technological marvel, equipped with unprecedented power, works like a giant magnifying glass, allowing scientists to reveal the intricate and often hidden details of distant planets, stars, and galaxies in ways we never thought possible. One of its most exciting missions to date, the JWST has set its sights on a truly remarkable target, K2-18b, an enigmatic exoplanet that is rapidly becoming one of the most intriguing objects of study in the search for life beyond Earth. When initial observations of K2-18b were released, they sent shockwaves of excitement through the scientific community. This was no ordinary planet. K2-18b has captivated researchers not only because of its potential habitability, but also because it seems to contain a molecule that is often linked with biological processes on Earth, a discovery that could mark the most momentous revelation in the search for extraterrestrial life. Could this be the turning point we've all been waiting for, the moment when we confirm that we are not alone in the cosmos? In this discussion, we'll embark on a deep dive into the fascinating world of K2-18b, exploring its unique features, the groundbreaking discoveries made by the JWST, and the far-reaching implications these findings could have on our understanding of life beyond Earth. So let's journey together to uncover the mysteries of this distant yet intriguing exoplanet. Located 120 light-years away from Earth, K2-18b is a super-Earth, a term used to describe planets that are larger than Earth, but smaller than Neptune. It resides in its solar system as a sub-Neptune, a type of planet that is unlike anything we have in our own solar system. While it is larger than Earth, it is smaller than Neptune, making it difficult for scientists to place it neatly into existing planetary categories. This unique classification presents a significant challenge for scientists who are trying to understand what K2-18b is really like. To put things in perspective, planets like Earth and Mars serve as benchmarks for much of our hypotheses about life and planetary conditions. Gas giants like Jupiter and Saturn provide tentative comparisons for understanding the behavior of distant planets. However, sub-Neptunes like K2-18b have no direct counterparts in our solar system, making them particularly mysterious and difficult to study. The data collected so far, however, has opened up some fascinating possibilities. K2-18b orbits within the habitable zone of its host star, a red dwarf known as K2-18. This is a region around a star where conditions might be just right for liquid water to exist, one of the key ingredients for life as we know it. Unlike the Sun, which is much larger and hotter, K2-18 is a much cooler star. This fact has a huge impact on the potential habitability of K2-18b. Despite the planet's proximity to its star, a mere 0.88 astronomical units away, significantly closer than Mercury is to our Sun, the lower luminosity of K2-18 means that K2-18b's surface is not completely scorched, allowing for the possibility of liquid water. In fact, this proximity has allowed scientists to detect the presence of vaporized water in K2-18b's atmosphere, a groundbreaking discovery that suggests the planet might have the right conditions for life. The fact that water vapor was found in the atmosphere of a planet so far away is a revelation in itself. But it gets even more exciting. Scientists have also detected a molecule that could be linked to biological processes, a compound, known as dimethyl sulfide DMS. This molecule is rarely found in natural environments on Earth, and when it is found, it is usually produced by microorganisms living in our planet's oceans. The discovery of DMS on K2-18b is incredibly significant because it suggests that, just like on Earth, biological processes could be at work on this distant exoplanet. If K2-18b does indeed harbor liquid water and has a stable atmosphere, it might have temperatures similar to those of Earth, a notion that becomes even more interesting when considering that the planet's atmosphere is likely to be dominated by hydrogen. This could make K2-18b's oceans slightly warmer than those on Earth, but it still opens up the possibility that the planet could have a unique and viable ecosystem. One of the most groundbreaking aspects of K2-18b is its classification as a sub-Neptune. In 2021, astrophysicist Niku Madhusudhan proposed a revolutionary idea in a paper published in the Journal of Astrophysics, the creation of a new category for planets like K2-18b. Madhusudhan coined the term hycean, hydrogen-enveloped ocean planets, to describe these worlds, which would be unlike anything we've encountered in our own solar system. These planets, he theorized, could have up to 10 times the mass of Earth and twice the radius. But instead of being boiling infernos, they could be warm, watery worlds. These sub-Neptunes could be surrounded by a thick, hydrogen-rich atmosphere and, crucially, a massive layer of water, possibly making up as much as 90% of the planet's total mass. This vast ocean could harbor the basic ingredients for microbial life. Sub-Neptunes like K2-18b could also have a much wider habitable zone than rocky planets like Earth. The thick atmospheres of these planets would trap heat from their stars, allowing liquid water to exist at distances from the star where, on Earth-like planets, it would be either too hot or too cold for water to remain in liquid form. This extended habitable zone makes sub-Neptunes ideal targets in the search for life beyond our own planet. The fact that these planets are also larger makes them easier to detect, making them prime candidates for observation by powerful telescopes like the JWST. Speaking of the JWST, it plays an instrumental role in the search for extraterrestrial life and has already made significant contributions to our understanding of K2-18b. However, even with advanced technology like the JWST, detecting the secrets of distant exoplanets is no easy task. It requires careful, deliberate observation, and this is exactly what scientists have done with K2-18b. To unlock the planet's mysteries, the JWST observed K2-18b during a celestial event known as a transit, when a planet passes directly between us and its host star. During this transit, light from the star passes through K2-18b's atmosphere, allowing scientists to analyze the light and identify the chemical composition of the planet's atmosphere. This technique works by separating the light into its individual wavelengths, creating a spectrum that reveals the fingerprint of the molecules present. By analyzing the light in this way, scientists can uncover crucial information about K2-18b's atmosphere, providing us with a clearer picture of the planet's potential habitability. If specific wavelengths are missing from the spectrum, it indicates that certain molecules have absorbed that light, allowing scientists to identify exactly which compounds are present in the planet's atmosphere. This is how researchers detected water vapor and, more importantly, dimethyl sulfide, DMS, on K2-18b. These discoveries are extraordinary. They not only offer a glimpse into the atmospheric composition of a distant world, but they also provide a window into the possible presence of life-supporting conditions far beyond our solar system. Still, caution is key. While the presence of DMS is promising, it does not confirm the existence of life. Scientists must continue to observe K2-18b and gather more data before drawing definitive conclusions. Other explanations, though less likely, must be considered. and repeated measurements will help verify the origin of this mysterious molecule. But even the mere possibility is thrilling. It signals that we are entering a new era in astronomy, an era where identifying habitable worlds and potential signs of life is no longer just science fiction, but a scientific pursuit grounded in real, measurable data. The James Webb Space Telescope is revolutionizing our ability to peer into the cosmos, and K2-18b may be the first of many discoveries that reshape our understanding of life's place in the universe. As we continue to study this remarkable exoplanet, scientists will use the JWST and future observatories to further analyze its atmosphere, search for more biosignatures, and determine whether this distant world might be home to the conditions needed for life to thrive. Whether or not life exists on K2-18b, its study brings us closer to answering one of the most profound questions ever asked: are we alone? The journey to that answer is underway, and K2-18b is one of the most exciting stops on that voyage.